Wait, wait. Is this the last section? Wait a minute, is this the last section? Yeah.
I would give a equivalent test date, very understanding. This should also be on the health calendar. Yeah, today for factory polynomial, and so this is the last day of music video. I think what's gonna happen is this test, as it falls naturally, the schedule would have been on next Friday. Because we have a flex day on Wednesday, so this would have been next Friday, which means the other classes have set on Monday, and for you to have it on Friday and passing down on Monday doesn't seem like fair to anyone. So it's like you don't get the weekend and you don't get much time to prepare, and well, it's much more fair to the other guys. So what I'm doing is I teach ahead. So before the unit one test, I'm going to be introducing the next unit next time. So next time is the next unit. After that, we'll have a review. So we'll review before the weekend, the test. They'll have the weekends, they go over stuff. Iron out anything you need to iron out. So you can come back on Tuesday and kill it. Right. So you can just do incredibly. Like if you're not happy with the quiz score today, don't worry about it. Don't worry about it. Right. It's just, it's just a hey, it's a note, like a notification to yourself. Say, this is what I need to do. And I'm happy you can do. You can see there's plenty of support. And let's get to it, shall we? Finish up this unit. You ready? Yeah. Would you please discuss with your neighbor what does it mean? What does the word factoring mean? What does it mean to factor or something? Okay. So it seems like you all have some sort of memory of factoring in your lifetime.
Yeah.
Yes?
Yeah.
Are these good fond memories of your past?
Yeah.
Hopefully it's not too painful. But I want to take it back to elementary school. The first time you saw factoring was like if your teacher may have asked you to factor the number 10. Does that something? Two and five. Are we good with that?
Yep.
If someone says 2 and 8, they completely misunderstand what factoring is, don't they? Because by nature, factoring means to turn something into a multiplication problem, isn't it? Factoring means to turn something into multiplication. I think that you already are talking about some details about factoring. I really liked it, and it was good to hear. But we're factoring. Make it. Well, let me make this legible first of all. Make it a product. Like this one right now. Is it a product? No, right now it's the sum of two monomials, isn't it? I just put the vocabulary type. What would be the vocabulary to describe it? Please check it in the I remember, let's see where cubic final. We have cubic because the cubic final. Okay, and we see that in these two polynomials, they both have
They have a variable, but specifically they both have an x squared and they both have a 9. So we're going to factor out that 9x squared. Does that make sense? Some people call this the anti-distributive property. Does that make sense? Yeah. Did you finish this already? I have a feeling you can. Go ahead and finish it. Check in with your neighbor, make sure they got the same thing you did. If you know it, I'd like to hear it on the inside on the count of 3. 1, 2, 3. 2x plus 3. Are we good with this? Now, I have a gesture that I like to do for factoring out the greatest common factor. It's this. Does that make sense? Okay. Thank you. All right. Not only am I pulling it out, I'm putting it together. Together. I like now I could have done this just like 9 times 2x cubed plus 3x squared. I could have done that. It is factored. But anytime I'm asking to factor out the factor completely, I have to find a factor of a greatest common factor, not just any old common factor. That's the way that X as well. So even if it doesn't say factor completely, I expect you to do as much as you can. For B, oh my gosh, they're getting to the thick of this quickly. How many terms do you see right here? Kind of convoluted, isn't it? I think you can multiply it out, but I want you to look at this as 2 terms. Remember, one term is expressed in multiplication. Here's one term. Here's another one. Do they have anything in common? They both have x plus 3. So why don't you do the x plus 3? Factor it out. Meaning, I'm going to have x plus 3 on the outside here. And what's left on it in the parentheses now? X squared plus 5. So same kind of thing in A and B. Any questions there? No? Are we good? Okay, factoring by grouping. I'm not sure why they put all that space there. I just want to get right into it. Oh, sure. Yeah. It's a B. Yeah, absolutely. I see that there are 2 terms. And thank you for asking, by the way. In both of these, they have, I didn't get the green there. They both have an x plus 3. Do you agree? So all I'm doing is I'm taking this out and factoring it out here. Once I factor out x plus 3 from this term, I'm left with x squared. If I go x plus 3 from this term, I'm left with just 5. I can go back to here if I take this full expression and multiply by x squared, and then this times 5 again. You see how that looks up to the thing? Yes. We don't do x squared, no, that x squared comes out, x squared and 3, and then factor that. Oh, like distribute? Yeah. That would work. I would call that what I like to do, leading group, because we're already done. When you could get to the answer that way, I think it would. Okay, I could definitely do that. So factoring by grouping. Oh, any other questions before I move on? Okay. This one, you take a look. We have 4 terms here. Is there a common factor? Like, yes, no, wait, yes, no, right? There is a common factor, but the only common factor is 1, which doesn't help. You can factor out 1 all day long and never get that done. What we're going to do is we're going to break this up a little bit, right? We take a look at this. Instead of looking at 4 terms, we're going to break it up into 2 and 2. Do you do this? Do you have the dexterity in your hands to do this? No. Let me check this out. Can you do this one? Oh, yeah. Oh, Joseph got it. Yeah, it's okay. Okay, you'll learn to use your hands one day. You're still young. It's okay. That's like the biggest tangent ever. No, no. Okay, so I'm gonna group this into 2 and 2. That's what I thought.
Okay, wait a minute, for these two, I could factor out x squared.
So I'm going to rewrite this as x squared times x plus 4. Now continuing on, what do I write next? It's still plus, and notice in those other two terms there is a 3. So what do I do with the 3? Factor out the 3, leaving us with x plus 4.
Now this should result in a tiny bit of happiness.
Do you see what I'm looking at? The happiness is right here. This and this match. It makes us happy.
It's not seen that many. You should make use of it from this right. Right? Oh, yeah. Go ahead and finish this problem. Go ahead and factor it.
Check with your neighbor when you're done or stuff.
Okay.
So from here we are left with, but we factor out the x plus 4, leaving us with, are we good with this?
Hey, look, we started with an addition problem and ended with a multiplication problem. It's called factoring. We made a multiplication. Let's check. How do you see if this is right? So, Jimmy, can you check in your head? Is this good? Yeah. It's actually kind of perfect. It's kind of perfect. So this could be the process I want to do that instead of guessing.
Factor by grouping. So good. Let's see if we can do B already.
Now there is, little sticky there.
We have the first step, check in with your neighbor. There should be a little happiness that happens here. Okay, let's make sure you did it. Did anyone get through this? You got it? From those first two, we factor out the x squared, leaving us with x plus 5. So far, so good?
Yeah.
Next, we factor out the, right, there's danger ahead, isn't there? Because we factor out the -2, leaving us with x. Is it plus 5 now? Well, if we do this,
Is this a match? It doesn't match. We have to factor out the negative in both.
so hopefully you did that already. If you missed that, just keep in mind, when you factor out that negative, everything else is got to change.
This term became positive, it became plus 5. And now we see that we have happiness. You love it, yes, you do.
And from here, did you finish it now? I like to start with the one that is factored out. So if you know it, let's hear it on the count of 3. 1, 2, 3. The one that's factored out first, x plus 5 times Okay, we definitely need to practice that more. Breathing more instinct, right? It needs to be like original and everyone on the same page, otherwise nothing. So I don't want just like I'm on page 3, I'm on page 5. Is it right to 50? No, it's fine. What problem is that problem? Yes. I'll probably ask you that every time we do it, and I won't put that on the text. Probably. But you never know. Probably. It won't be a big part of the test. If it's anything, it'll be like just half. Anyway, moving on. Just kidding, it won't be half the test. Okay, factoring trinomials. Dun, dun, dun. Okay. Do you remember how to factor these? Yeah. Yeah, you did definitely did these in Algebra 1. For sure. Question, do you remember how to do them? Can I tell you the absolutely wrong way to do this? The one that you'll get the problem wrong every time, and I see people do this sometimes. They just do this. They just say, okay, it's factored now. Yeah, no points for just adding random parentheses on stuff. I can't even say nice try. You can't even do that. Yeah, it's just a 0 there. Okay, so I'm gonna tell you a method I don't love, but it works. Has anyone seen this? It's called either X method or the diamond method. And I'm gonna teach it to you a little bit harder, and then I'm gonna ask someone to tell me how how to simplify what I just did. But in the top of this X goes the number, specifically number 8, number 8. Yeah, the C, right? The third term. In the bottom of this X goes the 6. Right? It's always going to be 8. So whatever number here, here. And now we play the game. What two numbers multiply to 8 and add to 6? In this case, it's not just what to find 4 and 2. Easy? Are we done with the problem? No, we haven't done any real math. So we need to make this a multiplication problem. Okay, so the next step, I'm going to take that 4 and the 2. And I want you to put your pencils down and just watch the rest of this process now. I don't want you to get lost. So as soon as you finish what you're writing, pencils down. That 4 and the 2, what I'm going to do is I'm going to take that middle term, that's 6x, and rewrite it as 4x plus 2x. And then plus 8. Okay, when we do algebra, I need to write the same thing. From here, I'm going to factor by grouping. I'm going to factor by grouping. You can factor by grouping. Okay, so you did this, you factored out the x, I hope. Here you factored out the 2, got a little taste of happiness right there, and then you factored out the x plus 4. I'm going to try this again. On the count of 3, we're using this method. On the count of 3, I would like to see your the next step. 1, 2, 3. Okay, better practice. Okay, that's nice. Raquel's happy about the progress we're making. We're going in the right direction. We're going in the right direction. Raquel was a little bit slow. I have to say a little bit slow, but you're on board. That's good. Yeah. So we have reversing. Yeah, I'm not gonna have to. Now, how many of you could write from here to here? How many of you could? Can we do that by?
Okay, so because it's plus plus, this is plus plus. Okay. I'm not correct, it's plus plus here, it's already plus plus here. Yeah, yeah, but you're right, there's too many different cases. Okay, right, what multiplies eight and adds to six. Okay, right, it's kind of like we went through the whole process. I'm doing this process because as it gets more complicated, what you're talking about starts to fail. But when the leading coefficient is one, this always works. 4 and 2 right here, so x is for x is 2. It will work. I don't know how you get there. But this method will always work.
Any questions? Perhaps your question is, can we please continue with the lesson this evening? The answer is yes. I knew that was your question. I had a feeling. B, go ahead and factor B.
Whatever method you want to use.
When you finish checking with your neighbor, make sure they got the same thing you did. I'm not gonna do the X method. I'm just gonna hope that you got to X plus 5 times plus 8. Are we okay with that?
Looking at this, can you tell by looking at this is the same as this? Yeah. In your head, by doing what? Distribute, you go to the x squared, you go to the 40, so what's the middle term that's top, and the 40x, the 13x, you see it here, 13x? 13x, this and this, how is it? You get this ladder.
Okay, so they are equivalent, and now comes the negativity. Exactly, we're gonna need a little bit of plus and minus behavior. I can use the X method. You could use whatever method you like. What is this? 6 and -3, is that right? I think so. Are we good up to there?
You don't get that? And I think if you go right, exactly the same as well. What's the number to multiply the negative 18, have to be 3, here, that's a plus 6 and minus 2. It will not say, as long as the leading coefficient is. Leading coefficient is 1. Let's talk about leading coefficient, I'm talking about the coefficient at the height. Weight,
Okay, go ahead and do D. Whatever method you like. Maybe you already finished this like 5 minutes ago. Thank you for your patience. Okay, so in this case, it's going to be X. What do you think? Let's say X, start with X plus 2 and X minus 7. Okay. Moving on. Yeah. In your mind, you may ask yourself the question, what number multiply to 3 and add to, or -3 and add to be -10? There's no answer to that. And it's an improper question to even ask yourself anytime the leading coefficient is anything but 1. Here it's 8. So we are going to use the X method. This will always work, and it leaves no room for guessing. Now, the number on the top is not -3. Does anyone have any idea what that number on top of this X will be? It is -24. Do you all see where that came from?
What?
Yeah, the product of the first and last coefficients. And the underneath on that bottom will be is -10. So the bottom is the same thing. It's always that middle term there.
The rest of the game is the same. Find two numbers that multiply to -24 and add to -10.
I'm thinking like -6, -4.
-6 and -4.
Yeah.
Are we good with that? -6, -4?
Wait, no.
No, because
Oh, wait, these multiply to +24, so they add to -10, but yeah, first order of business to make sure they, is there anything? Oh, -12 and 2, does that work? Next step, what do we do? Should I just go right to the parentheses and put a -12 and a 2 in there? Using the X method, we rewrite the trinomial as a quadrinomial and then
And
and then you put the
factor by grouping. Can you do this already? Rewrite this as a quadrinomial, factor by grouping, and then oh, that's so many polynomials. It's like, oh, you're sleeping.
Oh, no, it's really happy.
I want to see it. What are we doing with that -12 and 2? Rewrite the trinomial as a quadrinomial. Simply neighbor, what's the next step when using this X method? Okay, folks, remember the next step is to rewrite the original polynomial. This 8x squared stays 8x squared. What happens with that -10x? So what is it?
God bless you.
There we go. This is the diamond method or the X method. Rewriting the trinomial as a quadrinomial. We have 1, 2, 3, 4. And now factor by grouping. This will always get you the right answer with the least amount of pain, theoretically. Go ahead and finish if you haven't already. Oh, this one, there is a little bit of a trickiness that happens there. Have fun. For the first two terms, we factor out 4x. Thank you. Leaving us with 2x minus 3. Now, the second one, do we factor anything out? We can't factor anything out. I want you to force one thing out. O1. Let's factor out O1. So this is going to be plus 1 times 2x minus 3. Is the result a tiny taste of happiness here? I hope so, because we have that matching 2x minus 3. Go ahead and finish the question. Or finish the answer.
Take that.
Quickly check with your neighbor, make sure everything is okay over there. Dare I do it? Do I even dare? Should I count to 3 and see what you got? Okay, and I want you to follow this, and so you know which one I want first, right? On count of 3. 1, 2, 3.
X plus 1.
It's like one voice. It's like one voice. I couldn't. It was just room 310.
Plus 4.
Yeah. Oh, look at this.
But we get it wrong. We don't put 2x minus 3. You don't have to.
No.
Oh, like if you switch it? There's a property that actually says A times B is the same as B times A, so. It doesn't matter. What property is that called? Commutative property. Yeah, so either way is fine. Oh, really quickly. Are we sure this is the same as this? Do you see the 8x squared? Do you see the -3?
Yeah.
Do you see the minus 10x? Seriously, do you see the minus 10x? Up here, do you see, down here, do you see the minus 10x? Obviously, you see it up here. Minus 10x comes from
Right then.
2x minus 12x. It's there, it's on there. Yeah,
Would you want to solve the problem behind on James Street?
oh no, that's very complicated.
But there's a problem with
Sure.
it.
Someone put a problem on your shirt? Oh, that's interesting. You have an X on your shirt.
Oh, well, that's fine.
That's funny. We'll have to work on that later. Okay, after number 6, we'll take a short, 2-minute zone out break. But go ahead and do it. See what you got. Maybe you already finished. Anyone already finished this one?
Yeah.
Alright. On it. No, I said someone had cool chat.
Oh, yeah. Oh, no, I learned this from.
What?
I learned this question. Oh, yes. No, I learned from this one.
Oh,
No.
No.
21 and no.
Oh, yeah.
Did you get it?
-2 plus 21. No, I got it.
Okay. I'll see if they get.
Yeah, I figured them out.
Okay.
Yes.
We give everyone about 30 seconds, and I'm going to ask for a volunteer to help us go through this. I'm going to pretend I have no idea what to do. And you're just going to be our guide. We'll put an X here. Are you ready? Well, ready or not, I need some help. Who can help me with this one? Anaris. Oh, thank you for your. Yes.
So first you're gonna multiply 6 times -7,
Okay.
and that's gonna go on your top box. And that's gonna be -42.
Okay.
And then right below that, you're gonna put which is B, which is 19.
Okay.
Have you think about what 2 base factors are?
Yes, exactly. Did you get an answer for that? 6 and 7? No? 1 and 42? I don't know. I don't know. 2 and 43?
21.
We have a teacher in the making here.
Number 2. So what needs to be negative so that you get 19?
The 2.
So then
I got an amen.
now what do you have to do? You have to rewrite it into 4, right?
4. Oh, I see. Oh, 4 terms. Okay. I see. I was like, this is a 4? What? Okay.
That's 21x. Oh, be careful with your negative.
Oh, yeah, I thought you said plus 21x, no? Okay, so 6x squared. Okay.
Minus 2x.
Okay. Okay. I feel like I'm getting the student experience here. This is good. Okay, keep on going.
2x plus 7 minus 1 times 2x. There you go.
I messed up there. 2x plus 7, huh? I'm suddenly feeling pretty happy. Okay. Take us home.
That's fun, it's fun. No, it's, yeah. Close that down.
Did she speak the truth? Nice. That was nice. That was nice. Okay, so let that sink in. We'll resume at 12:30. Sometimes you got to. Do you like this rapper? Okay. Do you hate this?
I actually really like it.
Joseph, what did it say? You don't? Can you talk to me, but can you talk me through that? Do you mind taking this? So then the A's which is these.
Better bad, yeah.
Two, so then you plug in.
Here. Is he going to-
Yeah, so then, and then you basically go like.
No, what's your next?
So
Oh, I thought you were talking about the fence.
B equals to B -3. Because this is the next square. I would actually go with like force. Yeah, but.
What out of what?
I'm sleeping. So I'm gonna do. Daenerys, what's your favorite dance?
It's red.
Yeah, it's just, I mean, I did it a lot last week, got everything on.
What?
I think we should do it, it's like, told you it's you.
What'd you guys? Wait, that's actually pretty. Wait, that's not really hard.
Yeah.
Buddy.
I know. It's chill, you got the most important. Yeah, I don't know how to do the feet. Oh, no. Oh my gosh, it's 12:30. Thank you for crazy people for.
Oh, wow, look at his line.
Hey guys, have a seat, please. Have a seat, please. If I have to ask that many times again, then there's no getting up to the board. Okay. Oh my gosh. Two variables? What? Not scared at all. I use the X method, also called the diamond method. On the top of this, X will go 6. Bottom of the X will go -7. Filling this in. I'll let you finish the box. It's, what is it? I hope you already got that. Did I do that? -1 and -6, is that right? As a multiply to be the top, add to be the bottom. But 2x squared minus, oh, we're just breaking that up, xy. I'll let you finish this. I'm sorry. Talking too much. Oh, is it? Thank you. It is minus xy. Good catch. Take your number, not your number, your neighbor about A, please.
Um,
I don't think I've seen
You can tell us the answer. Just Siri.
X minus 3y times 2x minus 1.
Times 2x minus y, you said? Do we agree? Is that the answer? Let's check. I don't know. I see a 2x squared. I always check the first and last terms. I see a plus 3y squared and minus 7xy. Perfection. Negative 6xy minus xy. That's nicely done. Any questions?
Words negative 6.
So if we're gonna do this,
Charge.
no, that's a good question. Factor out the x, we have 2x minus y, and here we factor out minus 2. Sorry, minus 2y, leaving us with positive 3x. Oh, wait, I'm sorry, you can't factor out a 2 from there. What am I talking about? Did I mess something up? I'm factoring out a 3 or negative 3y. Okay, which leaves us with 2x minus y. And there's our happiness. We have 2x minus y, x minus 3 right there.
Yeah.
Try B. Did I finish? Did anyone finish B already? Did you get it? Some people are still working. Let's see. 12 more seconds. Okay. The answer. Someone who hasn't given us an answer today gets first choice. Who likes to tell us what the answer is? It's so nice letting other people do it. Anyone who's given us an answer want to tell us what the answer is? Just Siri for 300. X minus 4y times 3x minus y, you said? Are we good? Fantastic. Thank you. Next. I remind you last time, hey gentlemen, if I multiply a plus b times a minus b, should I use the distributive property? Perhaps you remember that the answer is always going to be a squared minus b squared. When you're adding in this situation, when you multiply these out, the result is always, what is this expression called? It's difference of squares or difference of two squares. So the fact that these are equal means that this could go either way. If we start with the difference of squares, we can change that into a plus b times a minus b. In other words, it's pretty easily factorable, going from a difference to a product. In your mind, when you see this, I want you to think, hey, that's a difference of two squares, isn't it? We can factor that. Do you already know? X plus 4, x minus 4. The biggest problem here is that some people do x plus 16 and x minus 16. They're on the right ballpark.
Right track.
They're on the right track, but they went the wrong direction. Okay, so just make sure that they match. Like we see that minus 16 here, we see it here. B, is that a difference of two squares? Heck yeah, it's a difference of two squares. We know how to factor that. Should I use the X method? Not for this. That's for the trinomials. For this, it's difference of squares. You're saying 9x,
Then
then x plus 7 and 9x minus 7. Are we good? Okay. Let's do D first. Just make sure your neighbor is able to do this one. So this one is
6x plus 5, 6x minus 5.
6x plus 5 and 6x minus 5. Any questions? I'll have to tell you what's coming. I have to tell you. I don't know if I've told you before. Did I tell you about the cups? I'm gonna have some cups here in a couple of weeks. In a couple of weeks. What's that? There's gonna be some cups. In the cups are gonna be some popsicle sticks.
Oh, and then you can do like the picking.
On the popsicle sticks will be your name. Yeah, so that's coming pretty soon. And after a time like this, after a time, you've been able to give, like, to talk about it with your neighbor, and only then, and then draw a name and say, like, Mary, what did you discuss, like, with your neighbor? Like, and get the answer that way. So it'll only be after a time you've had to discuss. It won't be like, here's a question, what's the answer? It'll be after you have some time to discuss it. I just want to know that's coming,
I'm excited.
as you should be. I will be drawn many times. Mark my words. Oh, we gotta do this one. Is this a difference of squares?
What's the difference of yours?
It is definitely a difference of fourths, but is it a difference of squares? Yeah. Well, we know that 81 is 9 squared, but x to the fourth is, it's x squared squared. So we could factor this into x squared
Plus 9.
plus 9 and x squared minus 9. What do you think? Any question? Perhaps your question is, should we finish the problem?
Yeah.
Do you know what I mean by that? Should we finish the problem? Why would that even be a question here? Yeah, because we have a difference of squares. We're not done. When it says to factor, it means to factor completely. Can we factor the sum of squares? Not yet. Not yet. Not until we get to imaginary numbers. So we're gonna leave it like this. X squared plus 9 stays there, and then x squared minus 9 becomes x plus 3, x minus 3. Are we done now?
Never done. Oh, we're done. We're done with this problem. How can we check? Multiply it out. Or just trust that what you've done is correct.
I mean, why
That's
don't you
just
just like bring
Then
it?
why can't you do x plus 3x minus 2? Excellent.
Oh, like here, one factor this. Good question. Thank you. Before I talk about that, any other questions about this problem aside from that?
No,
Thank you for asking, by the way. Now we've established that a cubed minus, sorry, a squared minus b squared is that. And I think we're comfortable with that. Let's see if we could factor a squared plus b squared. If I want to factor that, it would probably be a and a, wouldn't it? Here and here. This would be b and b. And then these are both plus. Is this true? Are these equal to each other? No? If I were to distribute, I see a squared, I
they
see
are
b
equal.
squared.
to
But also I see
No.
AB plus
No.
AB. So this is actually, you may remember a plus b squared. This is a squared plus 2ab plus b squared. So these are not equivalent. So if this is not how to factor a squared plus b squared, how do you factor it? Okay, is there anything I can put here? Maybe negative and a positive? No, that would result in a minus b squared, wouldn't it?
Negative.
Negative and negative?
You can do a negative one on the outside.
Or negative on the outside? That's an interesting idea. I'm afraid there's no answer to this question, unfortunately. You could try lots of different things, but when you multiply it out, none of them will result in a squared plus b squared. This is a known prime expression, so we just leave it. So a sum of squares, prime. Difference of squares, we know how to factor that. It's always going to be this. This is huge. This is every algebra 2 every algebra 2 student's favorite thing to factor. It's just like nice. You get it right every time, theoretically. Okay, for these problems, I expect you to either use the X method or just a method that what times what is 9 and added together is 6. But the fact that this is our answer means you can rewrite it as X plus 3 quantity squared. When you see the same factors, just consolidate these.
So on the test, we should simplify the X.
Put them together. Yeah. We always want to be as efficient as possible with our notation. Probably.
What?
Not a lot. And if it's like a bunch of problems, it would just be 1 point out the quarter. So total would be like 1, 1, 1, 1.
If like you keep it.
So if you leave it here,
that one?
you'll get a. I want you to consolidate. Just keep that in mind. Right, I'm telling you straightforward here, so no surprises. So this problem. Oh my.
What? Dude?
Oh my. I'm gonna leave this as 25 times 36 at the top. Bottom is negative 60. And I'm gonna break this up into 5 times 5 times 6 times 6. Is this enough to what's out with this? Oh yeah, I think that's enough. Now I can break this up into 3s and 2s again. But just this is enough for me to see the negative 60. Do you see it? 30 and 30?
Oh,
30 and 30. Or negative 30, negative 30. Maybe it would have been easier just to get the 900 up here. Maybe that would have been easier in this case. Except getting that problem is a pain. And now we can see the negative 30 makes sense, etc. Ultimately, you're going to end up with 5x minus 6 quantity squared.
Be able to have a calculator.
No. Yeah.
I'll try not to have problems like that, but I do expect you to do 36 times 25. You discuss quickly how you would do 36 times 25 if this came up on the thing. Would that be?
Yes.
How would you do that? Yeah.
Five times.
Okay.
Correct. Divide up the 150.
Okay. Now, hopefully, you could do this.
Yes.
900.
900 obvious.
That's crazy. I do need you to be able to do this, but I hope that you agree that doing this kind of sucks.
Yeah. Yes.
Do you agree with that? Doing this kind of sucks. We kind of hate it, but it's a necessary evil.
Yes.
So there are times that I need you to have mental tricks to avoid this. And this is one of those. How can we use a mental trick to avoid this?
And you can do 30 times 25, and then do 6 times.
So 30 times 25. And then add 6 times 25. I agree. I'm much better.
Like, what is that?
25 times 3 is 75, and then 75 is 72.
Here's my suggestion. For 25, think of
50.
money. Think of money.
Really, I just.
So when I say 36 times 25, how about you just say, how much money do you have if you have,
25 quarters.
this is a quarter.
Yeah, you have.
So if you have
25
36 quarters, is that what this is? If you have 36 quarters, think how you would do that problem. Divide by 4. What's 36 divided by 4? We're talking about cents here. But that's where that, when you have that 25, use the quarters method. I think it's nice to apply. And if you think your answer is 9 here from 25 times 36, we have a little bit of a problem. You have to adjust that decimal. As a suggestion. I'm just gonna do one more problem because I really want you to have some time in class to work on these. I do D here. Yeah.
These are good problems.
Yeah, these problems like this will, the other ones will be on. Yeah, definitely work on these. What do you see?
We can establish some stuff out.
Factor some stuff out. We want to take out everything that can be taken out, specifically x squared. Anything else? 3 goes into 48. We check to see if your neighbor knows the trick to see if 3 goes into a number. Do you know the trick? Yeah, you add the digits. 4 plus 8 is 12. Now we think
4.
It does.
does
16 times 3.
3 go into 12?
Yeah.
If you're not sure that 3 goes into 12, we have to talk to you, but yeah, it went into.
Yeah.
Three go to 3. Yeah, so it definitely goes in here and it goes in what, 16 times? So I'm gonna take the 3 here. We're left with 16 squared minus 1. Am I done with this problem?
No.
That's some passion right there.
No, we have.
This is a difference
What's the difference?
of squares, isn't it? So we see a difference of squares, we factor it into 4x minus 1, 4x plus 1. Done. Okay. You got a few minutes to open up your laptops and get started on homework. I hope that today makes sense.
Very much sense.
It was a good day.
Yeah, first results, not what I hoped for.
Not what we hoped for, none of it got perfect. Small set. Huh?
Llama.